All right, our last example in 12.2, we're going to talk about marginal average cost. Ooh, there's that word again, marginal, right? And as soon as we see that word marginal, we know we're talking about a rate of change or a derivative. We've talked about rates of change. We've talked about marginal cost, marginal price, marginal revenue, marginal profit, and now we're going to talk about marginal average cost. We're going to have all of these types of problems not only on the homework, but also the chapter test. So it's really important to practice these, not only in the examples now, but also in the homework, as many times as you need to make sure that you understand, okay? All right, so we've talked about marginal cost, but marginal average cost is a little bit different. We all know how to find an average, right? We add them all up and divide by however many they are. Well, that's what we're going to do with cost. In order to find the average cost, we take the cost function, c of x, and we divide by however many we have, or x. This is going to give us our average cost. They symbolize that with kind of a little bar over the top. So if this is our average cost, adding them all up and dividing by however many there are, then how do we find the marginal average cost? Well, we take the derivative. And remember, how do we take the derivative if we have a function on top and a function on bottom? Well, we have to do our quotient rule, right? So that's what we're going to do. We're going to apply this by taking the derivative of our average cost, our marginal average cost. Let's look at example 4. Suppose the cost in dollars of manufacturing X hundred small motors is given by this equation. So this is the cost to produce a certain number of motors in hundreds. So if I said 15, I'm really talking about 1,500 motors, right? The first part says find the average cost per 100 motors. Now, average cost just means I'm adding up all the costs and I'm dividing by however many motors I have. So I'm going to find the average cost by taking my cost and dividing by however many I have. If my cost is the 3x squared plus 120 over 2x plus 1, then I want to take that and I want to divide it by however many more motors I sell or produce or manufacture. But if you look at that, I don't really like it because it's a triple layer fraction. So instead of dividing by x, couldn't I really multiply by the reciprocal, 1 over x? What that would allow me to do is put my numerators with my numerators and my denominators with my denominators into one nice fraction with just one top and one bottom. I would end up getting an average cost of 3x squared plus 120 over 2x squared plus x. I distributed the x through. This formula, this equation, represents my average cost, adding them at the cost and dividing by however many motors I have. This is not my marginal average cost. It's not a derivative. This is just my average cost, so be careful. A lot of students, since they've already done so much work, feel like they're already done with the problem and can plug in now, but really this is just the average cost. So in part B, when I ask you to find the marginal average cost, that means I need you to take that equation and still find its derivative, right? I need you to find the derivative of that average cost equation. So if this is our average cost equation and we need to find the derivative, we've got to use that quotient rule. We have the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Let's go ahead and distribute. Let's FOIL and then distribute a negative through. Pause the video, distribute your 6x, FOIL, and distribute your negative, and make sure you have the same terms I do. You should end up with a 12x cubed plus 6x squared minus 12x cubed minus 3x squared minus 480x minus 120. After I distributed, FOILed, and distributed the negative, you should have the same things I do. Of course, over that denominator squared, right? All right, after I combine some like terms here, it looks like the 12x cubed and the negative 12x cubed cancel. It looks like I should be able to take the 6x squared and the negative 3x squared and combine those into a 3x squared minus 480x minus 120 over that denominator. So this equation represents my marginal average cost, the rate at which my average cost is changing, right? All right, the last part in this question says, we shall see in the next chapter that average cost is generally minimized, and that's what we want. We want our average cost to be minimal, right? We don't want to spend a lot of money making these motors Our average cost is minimized when the marginal average cost is 0. So we have a marginal average cost now, right? If this is our marginal average cost, we can minimize our average cost as soon as that equals 0. So find the production that would minimize our average cost. Well, that means we need to make sure that our marginal average cost is 0. We've got to take our marginal average cost and figure out when it equals 0, and then solve for x. And that'll tell us how many hundreds of motors we should try to produce so that our cost is minimized, right? All right, if I have this equation now, and I take 0 and put it over 1, I can actually cross multiply. 0 times 2x squared plus x squared is just 0, and 1 times 3x squared minus 480x minus 100 is just that. So now I have this quadratic equation that I need to solve for x. You can try to factor, or you might have to use the quadratic formula, or if you know how to find the zeros in your calculator, you can use your graphing calculator to find x. It's a quadratic, it's a parabola. We know that because we have the x squared. Our parabola should open up because of that leading coefficient being positive. So what we want to do is we want to figure out at what x values does this equal 0. We want to find where it touches the x-axis. Again, you can do that by using quadratic formula. Hopefully you remember that from your previous algebra class. Or you can use your graphing calculator to find the zeros. What I'll do is I'll post another video that'll show you how to do that in your calculator so you don't have to do quadratic formula. Okay? So watch the next video that tells you how to find the zeros in your calculator so we can solve for x using our calculator. Until then, when you solve that, you end up getting two answers, right? Two places. I ended up getting x equals negative 0.25 and x equals 160.25. Now, what did x represent, though, in this situation? Didn't x represent the hundreds of motors? Well, it wouldn't make sense then for x to be negative 0.25 because we can't produce a negative amount of motors, right? So the negative answer wouldn't really apply in this context. But it would make sense for x to equal 160.25. If x equals 160.25, then that means we have 160.25 hundred motors, right? And so if I multiplied by 100, I end up actually getting 16,025 motors. What that means is that my average cost is going to be minimized when I sell 16,025 motors. So if I'm this company, if I'm this business owner, that's the number I want to shoot for, 16,025 motors, so I can minimize my average cost. All right, make sure you watch that video on the calculator if you'd like to learn how to find the zeros or solutions in your calculator, or make sure you practice using your quadratic formula. If you remember, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which in this case, your a would be 3, your b would be negative 480, and your c would be negative 120. Either way, we should get the same answers, negative 2.5 and 160.25, okay?